Alright, in this tutorial we'll be provisioning an EC2 instance with Terraform, and it's not just about provisioning it, about the results. I'll explain the step-by-step process of how to provision it and understanding each part of the Terraform configuration. So let's begin. So there are a few things that you need to have right before you can provision an EC2 instance with Terraform. So the first thing here is that you need to have, obviously, you need to have installed Terraform on your computer, right? Secondly, you need to have installed your AWS CLI. So let's check these things, right? Let me check it. So first of all, I'll create a file. So let me just go to my let's see, let me create like a folder. Let me go to my documents. You can go to any part of your of your system and just create a file. So let me call it Terraform EC2, because we are trying to provision an instance using Terraform. So just to give it a name, then it comes to your VS Code, click on file and then open a folder. We are trying to open that exact folder as a document, so I click on it and I open it. So okay, it's opening. Some other things that you need to have an AWS account already, right? So here we have the folder is opened. So in this place, the first thing that we need to do as regards creating and provisioning this EC2 instance, even before we start at all right, because this is something that I learned. Anything you want to do, right, as a software engineer, a DevOps engineer, there are documentations regarding it, majority of the things you want to do. So what we will do first, right, I'm not going to do anything half-head because I want you to understand every process. So we'll go to the documentation. So let's go to Terraform documentation. That's not what I want to type. Can type Terraform documentation for creating an EC2 instance. Alright, so where we want to go to is the documentation. Okay, so here we are. As you can see, it brings it out. Let me go back. There are two things that came up. There are two things here. There is the Terraform registry, and there's the HashiCorp documentation. So Terraform is owned by HashiCorp, right? And okay, so if you look at here now, in this Terraform documentation we have here, this is Terraform registry, right? This is Terraform documentation itself. In this place, you would see that even Terraform already gives you a tutorial, right, on how to create infrastructure in the cloud, which is something that you should look at. So I don't want to just create another a video like most of everybody else, just create it, walk through it very simply, without helping people that are just learning to have a full grasp and a very detailed understanding of what they are doing, which is something that I'm trying to solve here. So if you look at here, right, you would see, and this is something that I need to tell you, go to documentation every single time you want to do something. Don't just go to YouTube videos, right? No, you can do that probably to just have a grasp of what is going on, but documentations give you the step-by-step process, because people that developed what you are doing, they've written how to use it, so they are the best person to tell you what to do with it. All right, somebody else may have experience using it, but it was not part of people that created it. So we should have a better way to teach you. The people that created it, they know the in and out of it. So from this documentation that we have here now, let's look at it. You can see, like I said, the prerequisites here. First thing, you have to have the Terraform CLI, right? That's the command line interface, right? The AWS CLI, these are things that you can download. So if I open this place, for instance, if I open this link, Terraform CLI, install Terraform, you can download it. Let's see here. If you're using macOS, Windows, Linux, I'm using Windows, so this is it. You can go to your command line. In Windows, that's CMD, right? On Mac is a different one, right? So you can just put this command and install Terraform. But I already have Terraform installed, right? Let me show you that I have it installed. All right, let me show you. Let me open my terminal, new terminal. Let me show you how it installed. The command to check is Terraform version. Okay. Okay, yeah, Terraform version, and then you would see that I have a version of 1.29 installed on my Windows. Although the latest version is this, right? But I have Terraform installed basically on my system. That's what I want to confirm for you. So let's go back. Alright, so this is how to install it. If you don't have it installed, this is AWS CLI. You have to install it as well. Let me open it so that you can also see. You have to install it as well. It's very simple, right? Just go to your command line interface, your what do you call it now? Your command line, command prompt on Windows, on macOS, your terminal, you know, as the case may be, and just run those commands. It's very simple and straightforward. So to install AWS CLI, you have different operating system. I use Windows. If you use this other one, you can check it. So when you are using Windows, for instance, just run these commands. Just read through this place properly, and then you will be able to do it seamlessly. So if I want to check the version, just to confirm I have it right, the command is AWS --version. So let's check that on my. Let's check that here. So AWS --version. As you can see, it should come out. Okay, so I can see now I have a version of 2.15.16, right? So I have them installed. If you don't have them installed, make sure you have them installed. And let's see something else that we need to put in place. Is you have to have an AWS account. If you don't have an AWS account, just go to AWS account, browse it. Just browse it like this. There's no big deal about it. You can sign up for a free account. You go through the process of signing up, you know, and it's a very simple process. Just go through it, understand it, and that should work. There should be no issue with that. Alright, so let's continue. So you can see it tells you that the tutorial in this collection qualifies under free tier. So there is something called free tier in AWS. So you as a new user, it gives you some allowance or credit, you know, to run infrastructure to test the platform. But yeah, let's move on. So the first thing we need to do, right, like you can see here now, it tells you that you need to create a new directory. Basically, I'm just creating a directory where we want to have all our Terraform files, configuration files in. So let me do that, right, and just do it side by side so you can see what I'm doing. Side by side, yeah. Okay. Let's take this down a bit. Let's drop this. So here I am, as you can see now. Okay. And you can copy this and paste it. So what we're basically doing, we are trying to create a new directory. A new directory called learn Terraform, get AWS, get started AWS basically. So if you don't know what a directory is the same thing as folders if you're using a Windows system. So that's just the same thing. So I've created that directory now. You can see it here. That's shown here, right? It's a directory, it's a folder, like you can see here. So it tells you to go into that folder, right? CD means change directory. So you want to change directory into you want to go into that folder, because currently I'm in this Terraform EC2. I want to go into this place. So I just CD means change your position in the directory. So we go into it, and yeah, we are there now, right? So if I do pwd present working directory, it tells you that I'm inside that exact place. Let me yeah, I'm inside that exact place. Learn Terraform. Yeah, as you can see, get started AWS. All right. So something I need you to get here is this. I will go through. I'll read this place so that we can really understand. Right? There's no rush. There's no need to rush. Since Terraform configuration files are plain text files in HashiCorp configuration language, HCL. So HCL is a language that was invented. Let me use a word by HashiCorp, right? The same way you have some programming language, but this one is a configuration language to configure things, right? Infrastructures in the cloud in this context. So the extension for it is .tf, right? Every programming language, every language has an extension. Even Markdown is .md, you know, HTML, .css, basically. So for writing Terraform configuration file, the extension is .tf, which means Terraform, right? Terraform files. So it says when you perform operation with Terraform CLI, right? Terraform loads your configuration file in a current working directory. That is where we are currently now. So when we are performing an operation, which you would see as a proceed, right? What Terraform does is that all those operations are performed in this directory. Everything that we are doing happens in this directory. So, and it says this allows you to organize your configuration into multiple files in order to choose in any order you want to choose. So you will see that working. Let's go on. Terraform configuration is organized in a few types of blocks that let you configure Terraform itself. So we have Terraform providers, Terraform resources, data sources that make up your infrastructure. These are building blocks of your infrastructure. We will see that. So the first thing that we have here is a Terraform block. So let me show you how that looks like. It looks like here. So Terraform block configures Terraform itself. So you are trying to configure Terraform itself. Let me show you what that looks like. So what we need to do is to create a new file and call it terraform.tf. right? This file, this configuration file, you want to use it to configure Terraform, and you want to use it to also state and configure the required provider that we are going to use in provisioning our infrastructure, right? Okay, so if you look from here, right, a file has been created like I just created here. Good. Secondly, you can see this file here. So what I'm aiming to do, one of the things I'm aiming to do in this tutorial is to explain in detail what this is. Not just copy and paste it and it works, right? That doesn't make you an engineer. I learned that the hard way. So you need to understand what is he exactly doing, so that when something goes wrong, you can read the error codes, you can troubleshoot better because you have understanding now. So look at this. Terraform uses binary plugin called providers to manage your resources by calling cloud provider API. So the way Terraform is able to create infrastructure in AWS is by what we call providers, which are binary plugins, like you can see here. And how does it do that? Those providers, they are able to communicate with your AWS API, or let's say if you're using another cloud provider, in this sense, if you're using Azure, your Azure API, your Google API, Oracle, however the case may be, those platforms have their API. So the providers have access to communicate those APIs, and you can talk to those platforms. So API is just a way of communicating, right? You can tell it, I want to do this, I want to create an EC2 instance, and it communicates back, and things are done, right? So that's what I mean. And these providers, they are distributed and versioned separately from Terraform. That's what I was trying to explain earlier, when we saw this is a page for Terraform, and this one is different. It's also Terraform that owns it, but this is for a Terraform registry. A registry is just basically where you store artifacts, where you store things, right? If you know of Docker registry, you store Docker images there, right? So basically, that's where registry is for storage of things that you can access when you need them. So in this registry, we have a lot of things. We have a lot of things here which Terraform have provided for us. So in this place, right, there are various providers here. So if I kind of search for AWS, if I search for AWS now, you would see what I'm talking about. See, there are different providers of AWS here. So with these providers, I can communicate with the AWS API. That's what it means, right? If you see this, it says lifecycle management of AWS resources, including EC2. We're trying to create EC2. There are many resources in AWS: Lambda, EKS, ECS, VPC, S3. A lot of them, right? And HashiCorp, right, has been able to come up with this provider that can communicate with our AWS account to provision AWS resources. So even if you check, Azure, and the likes, you see Azure here, right? This will create infrastructure for you. The same thing you do in AWS, you can do the same thing on Azure there, because we have the provider that can communicate with Azure API. If you look at GCP, it's here also. So like many things, not just the cloud platform, different. Terraform is cloud agnostic, meaning it can basically communicate, it can be used on any platform, whether cloud provider, whether on-prem, whatever. But that's about that. Let's go on. So here, exactly. So this Terraform can support any infrastructure with an API. So because the Terraform provider is separated, right, from Terraform itself, because of that singular reason, Terraform can support any infrastructure vendor. So it's not logged into one cloud provider. Just like an equivalent of Terraform in AWS is CloudFormation. CloudFormation can only work with AWS because it's logged into the provider, into AWS. But in this case, Terraform is separated from its provider, right? So we can have all kinds of providers that can communicate with different platforms. So because of that singularity, because of that decoupling, Terraform can support any infrastructure, and that's why Terraform is popular, right? So let's go on the required provider. So in this place now, we're trying to create a Terraform provider, right? And then we are trying to put in the required provider. So let me just explain it in simple details. In this place, you want to state the version of Terraform we want to use, number one. Number two, we want to state what provider are we going to give Terraform access to, or what provider is Terraform going to be using to communicate with our cloud provider. In this context, it's AWS. So we are trying to state the AWS provider available in the Terraform registry, so that, because that will give us the ability to communicate with the AWS platform or cloud provider to create and manage resources. That's what we are doing here. So the first thing we have here is Terraform, the Terraform block, right? As you can see, I'll take it step by step. Even though I have autocomplete here, I won't use that because I want it to understand every single detail. So the Terraform block the first thing you can see, it says it configures Terraform itself. So apart from what we have here, right, apart from the required provider we have it in it, we want to configure Terraform first. The required version, just to complete. I don't want to delete it, but it's, you know, it goes faster than it ought to go. So now what you are doing in this block, you are configuring Terraform. So I'm saying the required version of Terraform I want to use is this. I told you earlier when I checked here, my version of Terraform, right? Yeah, is 1.9.2. It is not the latest one, right? But it still works. It's still provision infrastructure basically. So I'm trying to tell Terraform, I'm trying to say that this is a version of Terraform I want to use for provisioning my infrastructure. And one of the reasons why this is important is because if you don't put this, what just happens immediately is that it assumes the latest version, and there's issue with that, right? Because sometimes your infrastructure may not be compatible with a version of Terraform, right? Yes. So if you have not tested a version of Terraform, right, with your infrastructure, is not required. It's important that you put the required version or the required range of version that your infrastructure is compatible with. So in this case, we are saying that my required version is greater than or equals to 1 point. In this place it says 1.2, but I'm showing you based on what's my system. I have 1.92 here, right? So if I put 1.8 here, it's definitely not going to work because what I have installed is 1. Okay, if I have a sorry, if I put a bigger version here, it's not going to work, right? Because what I have installed is version that is up to 1.9.2, right? So, but I'll just put 1.9.2, right? So I'm saying that my required version of Terraform is anything that is greater than or equals to 1.92. So I have 1.92 at my version, but the latest version is this, right? So if it happens that my resources is compatible with something greater than it still works. It still works. If I still want to constrain it again, I can say 1.92 alone. But to give it flexibility, I'm saying greater than equals to 1.9, meaning 1.9.2, sorry, upwards to the latest version. So that should be clear enough. So now in this place, we are saying that the required version for our provider, in this case, but for the platform we are trying to provision a resource in, we are trying to say the provider for the platform we are trying to provision the resources, we are trying to specify the version and the source of it, which is important. So here, okay, let me see something. Okay, here we have required providers. This is the issue. Sometimes this is just too more than expected. Require providers. Oh my god. No worries, I'll type it. Require providers. Right. So the required providers in this context, AWS. But we want to use AWS provider because of what we are trying to provision infrastructure on AWS platform. If you are provisioning infrastructure on GCP, you use the Google provider, Azure, however the case may be, right? So in this case, it's AWS. That's why we are doing this. So we say AWS equals, yeah. Now, so you are okay. It's fine. You are trying to use AWS provider in the Terraform registry that HashiCorp has provided. So where is your source? Where is Terraform going to go to, or to locate the source of this provider, right? It's just like when you have a GitHub repository and then you want to, you want to clone it, you will include the the Git repository, which is the source of where you are getting that information from, something like that. So the source in this context is HashiCorp, right? As you can see, I'll just press the tab to complete it. Yes, to save me typing a bit. So HashiCorp AWS. So where this is located, right, is in the Terraform registry, and that's what I showed you earlier. Right, when I put AWS, this is what Terraform will go. This is where it will go to, and pull from. This is the source. Let me click on it so that you can see what I'm saying. So yes, this is the source that we have here. Let me even this is the source here. Alright, this is you can see use provider. So if you want to use the provider in this sense, just click here. You will see how you can use a provider here, which is what we are already doing, right? So Terraform is telling you that this is how you can make use of this provider, and that's what we are doing already. But yeah, I'm explaining it in detail to you so that you can just copy code and all of that. It can look fast, but in the long run, you don't understand anything. So yes, that's the source. So what Terraform does, this, okay, let's continue reading here. You will see what I'm saying. So it says here that, see, let's come to this side. It says HashiCorp maintains this Terraform registry, which is where I just took you now, from which you can source public Terraform providers and modules. So these things, they are a bunch of configuration files that has been created by developers in the Terraform community, right? And they just put it here. They are reusable, right? That's why I can go there and just use it, right? It has been there and they are being maintained, so I can go and pick it and use it. So now it's a set source and version as arguments. So these are basically arguments, right, that have a value, right? Yeah. So if you look at it, it says AWS provider source is this, which is also shortened version of this. So this is a long version, right, which is what I showed you here basically. What I showed you here basically. When you see that, basically, if you look at this source code, for instance, this source code is located in GitHub, right? It's in GitHub. See, it's in GitHub. Yeah, it's in GitHub. This is what this is what Terraform is going to look at. It's going to pull it from the GitHub repository. So I think that makes sense. So the version is, it's an argument, right? And in this case, I'm saying that what version exactly of the provider they want to use, because this provider are versioned. You have is in GitHub, as you can see, and GitHub is a version control system. They have different version based on how it's been updated, maintained. So what version do you want to use? And the reason why I want to specify this version again is because there's constant updates, and sometimes, right, a particular version may not be compatible with your infrastructure or with some code in your configuration files. So you need to look at a version that is compatible, and if you are going to use a new version, you have to test that it's compatible so that you don't fall into a lot of issues. Also, in this particular, oh sorry, I wrote argument. I'm meant to write version. I'm trying to state the version. So here, right, in this particular place, if you look at the version that we have here, you will see that we have the latest version is 6.28.0, which was published 3 days ago, right? So there are many other versions than this, right? You can see all versions. Okay, you can't see that from here, but you can see people have downloaded it and all of that. It's being used all over the world. So if you want to check Terraform versions, let me see. I don't want us to waste time on that, but you can search that very easily. What I'm just trying to say in essence is that these things are versioned in the version control system. For instance, like Git, yeah, Git basically. So the version that I want to use here, the latest version is 6.28.0, as you see. You can use it, but it's advisable not to always jump at the latest version, because you don't know what change has been, what update has gone on in that version, and unless you've tested it with your infrastructure, you've tested it and it works fine, that's the only time you are advisable to use it. You can't just, that's why it's not advisable to just say latest. If you know anything about even Docker images, right, you need to version it. Because if you don't put anything here, you just put, the latest version, it will pick the latest version. And this was 3 days ago. Let's say in the next 1 week, and that version is here. It will pick that, and you've never tested what had been changed in that version to know that it's going to work well with your infrastructure. So that's why we have version here. So in this context, I will just pick, let's say 6.20.2. Yeah, I'm actually picking at random, right? But a rule of thumb I use is that I don't pick the latest version, right? I just pick a version that is not the latest, that is still like not so in code the latest. So 6.20 is not the same thing as this, is a bit from 6.28.0. Yeah, so that's what we have here. And what this means is that use the version equals to or greater than 6.2.0. so it's meaning that it's compatible with any version that is equal to this, greater than this. That's what it means. So anything less than this, it doesn't work with it. So if my infrastructure is designed in a way to accommodate a version less than this, it's not going to work. All right, so that's what that means exactly. So if you read from here, you will see what I'm just saying now. So these things are not just something I formulated. No, I've gone through the documentation, I've read it, and that's why I understand it. And I want to take you through the process of me understanding it. I don't just want to just tell you. Right, I want to take you to the source of where I found it. So if you look at it, the version argument sets a version constraint for your AWS provider. Just read with me. If you don't specify a version constraint, Terraform defaults to the most recent version of the provider. So if you don't set a version constraint, if you don't keep it within a range, Terraform just use the latest version. And it says they are telling that we recommend using version constraint to ensure that Terraform does not install a version of that provider that you have not tested in your configuration. You don't know what has been changed in the latest one. If you just use it, they can have issues. Yeah, everything, your infrastructure can just be messed up. So this string that I just explained to you now means your configuration support any version of the provider with a major version of 5 and a minor version, okay, and a minor version greater than or equals to 92. Yeah, so if you know anything about naming convention, you know that this is a major version, this is minor. So it's telling you that it supports a major version of 5. In this case now I'm using 6, right? Using 6, and then a minor version of greater than or equals to 20. So this can change, can be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. That major version is constant until you have a major version of 7 again. It might take a while. All right, so that's what that means. And then this part of it is the same thing, right? Greater than or equals to 1.2 in this case, because we use 1.2 in this case. For me, looking at what I have here, right, because you have to check what you've downloaded on your infrastructure, right? You have to check it. I have version 1.92 here. That's why I'm putting greater than or equals to 1.92, because I know that the latest is this. So from year to year, there are still more other versions. All right, so I believe that should be very, very clear. So right now we've configured Terraform, right? Terraform, like it was said here about the Terraform block, it configures Terraform itself, including providers to install, right? And which version of Terraform to use to provision your infrastructure. So in this place now, we are configuring Terraform, number 1, and we are what? We are telling Terraform the provider you should install. That's AWS provider. We give it this where it's going to pick it from to install it, and the version that we want it to install. Are you seeing that? And the required version of Terraform that should be used to even install it. So these are the things that you're making sure you're putting down. So this should be clear about every detail of this place. So let's move to the next one. So like I did earlier, you can check your version, like what they did here. You can check your version. So let's go on to the configuration blocks. So we are done with the file, Terraform file to configure Terraform, providers to be installed, and the version that it should be installed and the source where you should get it from. So let's go on to the next file. So in this file, we need to create a main.tf file. Come to file, main.tf, right, good. So in this place now, you would see quite a number of codes here, the providers, the data. I'll explain it step by step. So let's read because you just need to read. In any field, you need to read to really understand. When it comes to depth, you need to read books, documentations. Forget about the blogs that people make. Go to the documentation itself. So it's saying that when you write a new Terraform configuration, we recommend defining your provider blocks and other primary infrastructure in your main.tf. So this is as best practice. So they are telling you this is best practice. You can go on YouTube and somebody do a different thing that is not best practice, right? That's why it's important to come here. So as you add to your configuration, you may choose to organize related infrastructure into different files. So over time, depending on how your infrastructure grows, you can break it down into different files. But for now, right, your main.tf file is where you should put your primary infrastructure and your provider. So the first thing that we have here is our provider, which is what? AWS, right? So where does that come from? It's coming from what we've already configured here. We said that our required provider, where our co-provider is AWS. So what I'm doing here is that I'm still referring to this file here, right? Providers is AWS. So what I want to do here is just to state the region where this provider, when it's communicating with my AWS cloud provider, what region should it install, or should it provision my infrastructure? Right? It should provision it in region. We have different regions. If you have AWS knowledge, there are different regions, right? Depending, a lot of regions all around the world. So this region, I'll be using US West 2. And the reason why I'm doing that, let me show you why I'm doing that. If I log into my AWS console now, you'll see what I mean. Just a minute. Okay. All right. Okay. I've logged in before, so it just signs me in directly. But if I was going to log in step by step, I would have to put my email, my password, or my email, my password, things like that. Yeah. So here we are now, right? If you look at here, I'm currently in this region, which is in United States, and then the region is called Oregon, which the code for the region is US West 2. I can switch to any region, but this is one I want to use. There's no preference actually, to be honest. But the only reason why we have all this here is that when you are provisioning infrastructure for your company, right, or for your services, you choose a region that is close to your users, so that your users can have fast access to your application, your services. That's the best practice. So if I have a lot of my customers, all my customers in the United States, I will just stay within this region. If I have a lot of my customers in, let's say, Europe, I will use one of these regions, because that would give them fast access to my services. It's called latency, right? So that's about that, US West 2. So that's why I'm using it. So that's why I have US West 2 here. There is this stuff called alias. It's just to give it a name. There's no big deal about it. It's just give a name. That's alias. I can name it Oregon, right? Oregon. which you saw there earlier. Oregon is. So that's that about this. I'm stating that in this provider, this is the region in which you should provision my infrastructure. And I'm saying the name of that region is Oregon, just an alias, just like you add a tag to something, a name. So the next thing you have here is data. So that's a mistake. Data. So these are data sources, and let's check what that means. Okay, it has been explained here already, right? The provider block configures options that apply to all resources managed by a provider, such as the region to create them in. These provider blocks configure the AWS provider, right? The label of the provider block corresponds to the name of the provider in the required provider. Like I said, it corresponds to what we have here already. So as we are basically building upon what we've written before. That's what this does. And then the beautiful thing is that when you read it, you will see that we can create multiple providers to do multiple things, right? So I can create another provider like this, right? And then let me just say that provider can be in another region. You see that? So I can say I want to provision another infrastructure in US West 2 as the same as this. Don't worry about this. This is my autocomplete doing it. So you can do amazing stuff with it, right? You can even do if you have, let's say for instance, a provider here. You've added a provider, let's say GCP, right? That's Google. And you can see that the source that is bringing out here is HashiCorp Google, which is located in the Terraform registry and doing intervention. You can come here, you can let me just take that away. Right. You can come to the main.cf and put that again. You can do amazing stuff with it. But we'll limit that for now. So another thing I need to say here, right? Because another thing I need to say here is that you need to make sure that your AMI credentials can authenticate to your Terraform AWS provider, right? It's very important. So that's when you install the AWS CLI, you need to run a command called AWS configure. Sorry. It will give you some prompts like AWS configure. It will ask you for your AWS access key. You input it here. Your secret access key, you input it, and the format you want your stuff to be generated, you input it here. But I've done this, so I would not be doing this. I've done this already. Alright, so I'll just cancel this, right? But if I want to show you that I've done it, let me just do AWS configure. You see what I mean? I also dash list. And to show you now, you see what I'm talking about. Just give me my credentials, right? And these are sensitive informations, right? So you can see over here. That my access key is this. It's a confidential thing, so it closes it. My secret access key is this, and my region is US West 2. I've already set it when I installed my AWS CLI and I configured it, right? So that's that about that. And the way you do this, if you don't really know it, is that you go to your AMI, that's Identity Access Management user in this place on your platform. This is an IAM user, it's not a root user, right? I created an IAM user for myself because it's not best practice to use the root user, right? So if you look at this place and I go to my security credentials, for instance, I created them here, and then I included them on my system so that there can be communication between the two. So it's those keys that give access, that allows my provider to communicate with my Terraform, to communicate with to allow my provider to be able to communicate with the platform. If you look at this place, you will see. Let me just see. So I've created access key from here. You can see I created it yesterday. It's currently active. You can see. Yeah, and it's last used in this region. So when I created this here, that's why I brought those details and I included it here when I run the AWS configure. So that's it. All right, let's move on. Control head. Yeah. So when it comes to this data source, right, in this place, these are data sources. That's the next thing we're trying to do here. And this data source, this data block is used to query your cloud provider for information about resources. So just for instance, you have a house. What are the things in that house? You can have shares, you can have different things in the house. That's the same thing. In your cloud provider, you've stated the region of your cloud provider you want to use as a US West 2. But now what we are trying to do here now is that we're trying to query, you can use this to query information about the cloud provider resources. Like what's the AMI of our EC2 instance I want to create? What's the Amazon machine image? That's AMI, right? So like details, you can go details so that when we provision our infrastructure, we get what we have specified already. So in this case, we're going to AWS AMI, right? And then the AWS AMI are trying to use here is Ubuntu. There are a lot of them, like you see. I'm also completely giving you Amazon Linux. There are a lot of AMI, Amazon Linux, Ubuntu, SUSE. There are a lot of them, right? So we're using Ubuntu in this case. Ubuntu is quite popular, but there's no preference. It's just to test out Cushion and EC2 instance with Terraform. Simple. So I will do this now. Right now, what does this mean? You are saying this data block is you are using it to query our cloud provider, which is AWS in this context, for information about the resources in the platform. As you can see here, to query your cloud provider for information about resources. This data source fetches data about the latest AWS AMI that matches the flitter. We'll get to the flitter. This is a flitter here. So you don't have to add code the AMI ID into your configuration. Data sources help to keep your configuration dynamic and avoid hard-coded values that can become stale. So it's not best practice to add code. Add code means to put the exact information there. No, it's important that you find a way to make it dynamic. All right, so let's move on. So now we've said that the information we are querying is the AWS AMI of the EC2 instance that we want to create, right? And what's that Amazon image? Ubuntu. Okay. The next thing that we have here, is most recent. So we are saying that give us the most recent Amazon machine image of Ubuntu. But we are not stopping there, right? We are not stopping there. We are giving it a flitter. And if you know anything about a flitter, think of a flitter. It's very simple. So now we have a lot of Amazon image that are Ubuntu. So we want to specify exactly which one, right? Because if you don't, it just picks anyone and you can run into errors, right? Yeah, when I was trying to do this earlier, I ran into some errors. So the first thing is the name, and you have the name. Okay. Yeah, the flitter is about about the name. Yeah, so name values. So what in this value you are trying to specify, right? Which exact image, right, should be used to provision our EC2 instance. So in this case, Ubuntu, as you can see, Ubuntu, you are using Ubuntu images. HVM, it means hardware virtual machine. The SSD type of GP3 Then you are going into that. We are saying this is the Ubuntu you should use, Ubuntu Noble of this version 24.04. You are specifying in detail AMD 64. Saver, you are going very detailed, very detailed, very detailed. You can see this when you come to, let me say EC2 here. You want to launch an instance. These are things, because for you to even come to use Terraform, you need to have understood how to do all of these, right, with your console. Because what Terraform comes to do is to be able to help you automate the tasks of provisioning infrastructure that you will normally do by clicking and clicking and clicking your console, which is very error prone and it's not consistent. So Terraform does that, automate it for you, make it simple. You can save it in a file, share with other people, and they can replicate the same results. So in this place now, if I just say this is Ubuntu, you can see a lot of Amazon machine image. There are a lot of them. So this is Ubuntu now. If I pick Ubuntu for instance, here you would see now that this is Ubuntu 24.04, long-term support, HVM, hardware virtual machine, SSD. It shows you all the details that are there. Yeah, exactly. All the details that are here. And even if you are going to look, see the provider is this Canonical. Yeah. So you can see it's Noble image, AMD 64. So we are not doing anything out of the blues. It's what's already here that we're trying to fix into here, so that we get the specified infrastructure provision. So let me just put in these details. We have Ubuntu images, HVM, SSD. Here we have GP3, right? And say slash Ubuntu Noble, right? We saw Noble here, right? You saw 24.04 there. It's not, and we saw the AMD 64 server start. Okay, you saw it here while we looked at it. So I'm not doing anything strange. You saw Ubuntu AMD Noble image. You see SSD. Exactly. So that's about that. So when we come here, the last part is the owner's part. So because these images that we're trying to use are owned by different I would say organizations. So which exact organization looking at? So because there are a lot of images that are Ubuntu, a lot of them. There are a lot of them that are even Ubuntu Noble, like a lot of versions. So we want to get to the exact one. So for that, we put in these owners, and this one is for Canonical. If you look at here, you will see that Canonical, right? You will see that you have it here. Exactly. Yeah. All right, let's go on. So 09, let me just auto complete. It's the same thing with this, right? All right, so that's about that. So what happens now is this. Let's read here. Data sources have an ID which you can use to reference data attributes within your configuration. So it says data sources ID are prefixed with data followed by the block type and name. So in this example, so if I want to access, let's say, the value of this I can say data dot AWS AMI dot Ubuntu. I send that dot ID. So this gives me the ID of this. So what would that do? Let's see from here. What would that do? In this example, data AWS AMI Ubuntu data source loads an AMI of the most recent Ubuntu Noble release. So what we just did here now, it would load for us the most recent, like we included here, of the Noble, which is this. in the region configured for your provider, which is this region. That's what that would do for us. Let me remove this. Okay. So let's move to the resource part of it. All right, we write resource. So the resource block here defines component for your infrastructure. The example configuration defines the resource block to create an EC2 instance. So you can see the difference. When we talk about the provider block, it basically defines what provider we are creating our infrastructure on. The data block tells us it helps us to query some information about the platform we are creating our resources on. So we want to create an EC2 instance. We are querying that the AWS AMI, in this case Ubuntu, of what the EC2 instance we want to create. So what the resource is, right, it defines the component of that infrastructure. So we are trying to create an EC2 instance. What are the components? The size, the tags. There are different things that comes with it. The size of the instance, the key. But we'll just stick with what we have here because this is just a very simple one. So the resource here, we have resource I want to create is an AWS instance, and I will show you this even from the Terraform registry. All these codes are there, but if you don't really come to Terraform documentation to understand it, you'll just be copying and pasting. So we are saying the resource that we are trying to put in here, we're trying to specify is AWS instance. The AWS instance value is a resource in Terraform itself. So let me try to check in that for you so you can see what I mean. So AWS, documentation. Come to documentation, you will see. So let's come to AWS. Just search AWS instance here. So before I even search there, from this AWS provider that is in this registry, if you go down, you will see what we have just worked on recently here, and even the provider part of it here. You will see it here. But let me go to the AWS instance part of it. It goes down. Let's just search for it under EC2. Under EC2, right? I meant to even check for EC2 first, so that gives me a direction. Under EC2, you check for the AWS instance. You go to I. Okay, here we have it. Right, you click on it. So here you can see it says provides an EC2 instance resource. That this allows instances to be created, updated, and deleted. So they've given you the code that you need here, right? The configuration file. So it says that this basic example using AMI lookup. So the way this creates an EC2 instance is that it looks into the platform AWS with the help obviously of the AWS provider. It looks up the AMI, the Amazon machine image that is there, and use that to create your instance. So what we are trying to do is here already, but if you just come and copy and paste and all of that, you won't really get the main part. But there are even other ways you can create an EC2 instance. You can use the AWS system manager parameter store. There are a lot of ways they can get things done. They're not limited, right? But that's not what we are going to. I just wanted to show you that. So let's return back here. Alright. So in this place, like I was telling you earlier, you will see now that let me see if I can. Okay, let's move on. So here you will see that this is the AWS instance is like what to call it now? It's like, let me see that here. It's a resource. It's a type of a resource on Terraform registry. AWS instance. There are all kinds of resources. AWS AMI. Let's come to AMI now. For instance, you see. See, it tells you, like, it gives you detailed things about AMI. So what we just did here is just simple. All we did here is very, very basic. AWS AMI, Ubuntu. It says it goes down to more details. Virtualization type, root device. You can go as detailed as this. And it explains everything here. So read through it, understand what exactly is it doing. But like I said, we'll take it a step at a time. So that's why we're doing this. So, but I just want to show you that AWS instance is a resource that is available in the Terraform registry that has been written down there. So the app saver is the name of our AWS instance, right? It's the name for it. I can call it web saver if I want, and which that's what I'm going to do. Calling it a web saver, and then when I open bracket double, okay. In this place now, the AMI that I want to use now. Remember that we've specified the AMI here already, right? So for us to get the information that we have here, we have to do data, which is this dot aws AMI dot ubuntu dot id. That in itself it retrieve, right, the detail of the AMI in it. That's what it does. Let me just do this. Okay, the particular detail of the AMI that we need to use from this block. Yeah. So the next thing is the instance type. I'll just auto complete it over here. The instance type is T2 micro. Yeah, if you look at from the AWS, you have all kinds of sizes of your instance type: T2 micro, T3 micro, T2 X large, a lot of them. So you are specifying it there. In this context, now we're hard coding this, right? For for a standard Terraform implementation, we are going to have like a variable .cf file that we're going to use for this. But in this context, let's leave it as simple as this. Then we have the tags, right? Tags are just like names that you give to things. I want to target this. I want to give it this name. So the name in this context, the name of my EC2 instance. This is what's going to show on my EC2 my AWS console. When I look at the name is going to be, let me use the word, I'll use learning Terraform for instance. That's the name that's going to show there, right? That's the name that's going to show over there. But this is the name I give to it that Terraform, picks. This is the name that is going to show on my AWS console. I mean, if that makes sense. So, but when we test it out, you will see what I mean in more detail. So if I read here for you now, you see, it says the provider developers determine supported resources type and their argument. So there are developers that have come up with all these things that I'm currently using. I'm making use of them, but they developed it. So they determine what kind of resource can be supported, right? The first line of the resource block declares the resource type and the resource name, which we have here. This is the resource type. I'm trying to make sure. And the resource name. In this example, the resource type is AWS instance. Okay, get what do you mean? This is a resource type. This is a resource name. And now tells that the prefix of this resource type corresponds to the name of the provider. If you look at the prefix of this resource type, which is AWS here, it corresponds to the provider that we have here, and that's how for every provider that's how it will be. If you have GCP here, which is for Google Cloud Platform, you have GCP, it will start with the resource. And if you want to confirm that, let's look at here. You see that everything here starts with AWS, every single thing. That's how the developers that came up with this have structured it to be. Everything starts like that. That's what we're trying to explain. Okay. So this resource address, okay, the resource type and the resource name form a unique resource address. So if I add this resource type and this resource name, resource type here and this resource name together, I can join them with a dot, right? It will give me a resource address. You'll see what that means in more detail. And that resource address, you can refer to it in any part of your application, right? Like we are doing this now. You are doing we've already documented this here. We are trying to refer to it here. I'm saying data.aws.ami.ubuntu.id. That's the address. So this now, in this place, Terraform knows that it will find out this, and it will come to you and find it out and see what is here, and look at the details. And it's from this detail that we have here under here that it will pick, right? It will pick the exact thing that I've put in here. All right. So if you read in more details, you will see what I'm talking about. The AMI, ID, stand type. Yeah. Why I'm doing this is to make you, understand that it's important to go through documentation. So now that we've written basically everything, we want to go into the process of provisioning it now. So the first thing we would do is to format our configuration. So because when you write manually, right, as I've been writing for a while now, the way my configuration file is formatted may not be the standard way, right? So to make it standard, I will just write a command, Terraform format, and then you will see it will be formatted. For instance, now this, okay, let's take for instance, this equals to sign here, this equals to sign here. Based on the configuration, is meant to be this. It's meant to be in the same place. Even this and this is meant to be like being. When I mean the same place, I mean something like this. Something like this. Yeah, the same place like this. Let me remove it and put Terraform format FMT. You will see that it will arrange it. Just take a look at that. Let's see. What did I just do? I'm coming. Did I just miss that? Okay, let me try that again. Terraform FMT format. If you read from here, it says that I'm coming. It says it's meant to change this stuff. The way you have it equal sign here, right? Is my resource part is meant to be like that. It's actually meant to be like that. Let me see. It says we recommend using a consistent formatting to ensure readability. The Terraform format command automatically reformat all configuration files in your current directory according to the recommended style, right? So if you format a particular file to bring out the file, min.tf. So it should actually do that. Let me do ls here. ls. Oh, I see what's going on. The file I created are outside of this directory. So let me take it inside. If you check, if I close the directory, it's not inside the directory. That's why it's not picking it. So let me drag it inside. Just drag it in. Move. Just move it. Simple. So you can see that there's a difference. Move. So that was why it was not picked. If I close it now, to close everything. So it means that these two files are inside now. That was a mistake. That's why it was not working. So if I do the command again on Terraform format, you would see that, for instance, this equal to sign here would be like aligned. Let's see. Can you see that? It just got aligned now. This is that, and it brought out the file that it had formatted. These two files. So you can see that. You can see that. You can see that. Yeah, you can see that. So beautiful. It's consistent with HashiCorp recommendation style. So that's what this does. So let's initialize our workspace. So basically, if you have used Git, you initialize your workspace using Git init, just to prepare your workspace to have the required things needed that need to be installed and all of that. So what the Terraform init does here is that it will download and install providers defined in your configuration in your working directory, because this thing it needs to be initialized so that you can even be able to do other processes, right? So let's see what we are talking about here. So For instance, in my main.tf now, in my terraform.tf, I mean, you have put in a version of AWS provider that we need. It will install. It will download. I mean, download this and install it, and it will also download this and install it. These two versions, because we need this to run this configuration for it to be successful. Those two things have to be in place. So let me just do Terraform init, right? And you'll see what is going to happen. It says initializing the backend, initializing provider plugin. So what it's doing now is that it's finding HashiCorp AWS, which is this. It's going to Terraform registry I showed you here, right? It's going there and it's finding versions that is matching this, and it says it's installing. He has found version, so it's trying to install it now. You see that now? And I told you that this is in a Git repository, right? And you have been version, so you went to find that version. Is installing it because we need that to be able to push in our infrastructure, be able to move forward to the next step. As we wait for this, let me just use this. You will see that after a while it will have installed it. It's signed by HashiCorp, meaning it has installed the version that has been developed by HashiCorp itself, right? Now the Terraform has created a log file. You would see that over here after a few seconds or minutes. So it has created a log file. It says that log file is .terraform.log.hcl to record the provider selection. So what this log file does is to record your provider selection. So what it has downloaded and installed, it will keep it in this log file, right? And then it says include this include this file in your version control repository, so that Terraform can guarantee to make the same selection by default when you run Terraform init in the future. So these things, like what I'm doing now, I can put it in my version control system like Git, and share it with my team, and when they are doing a Terraform init as well, it will pick the same version, so it's consistent, right? So it's working. It's working. It has brought out this file. You can see that now. It was not here before. That's part of the things that is installing, right? The license, which is by Terraform. That's why I told you. It said signed by HashiCorp. HashiCorp, everything is here, and then Terraform provider is here. It's still installing. It's still going to install a particular file .terraform.log.hcl, right? And even when we get to that place, even when we now apply our changes, it's going to give us a Terraform state file, right? That basically records the current state of our infrastructure, such that if we want to do a change on our infrastructure, let's say we have an EC2 instance and EC2 micro, which is what we have currently here, and let's say we want to change it to 3 micro, right? And we run Terraform apply, which you would see as we keep on going. What that state file does, okay, is done. What that state file does is that it will check what we have. It has captured the current state, and it would look at it with the desired state and know what change to make. So let's look at this. Can you see that the Terraform log file has been here? Can you see now? The same version that I told you about, the same version, right? And everything that needs to be done is here, basically. So let's read through what we have here. It installed the version. It didn't show the remaining part. It should have showed. Okay, it installed it here, signed by HashiCorp. It created a file like I told you exactly. Terraform has been successfully initialized. It says now you can begin with Terraform, run Terraform plan to see your changes, and things like that. So let's go on now. It has downloaded the AWS provider, installed it in an hidden file called .terraform that you see here. This is the file .terraform. Installed it here. This is the provider here. Yeah, the one we gave it to is in terraform.tf. This one, exactly. And specify the specify the exact version you used in your workplace, ensuring consistency before it runs. So that's what I'm trying to say. Consistency is very important. So the next thing we want to do now is to validate. So we want to check. First of all, we did Terraform format to make sure that our formatting is consistent with actually corporate recommendation style. Now we want to validate if what we have even written in our Terraform file, our configuration file, is even correct, right? Based on Terraform syntax. You can see it says make sure your configuration is syntactically valid and internally consistent by using Terraform validate command. So you want to check it. Is it correct based on the syntax? Because if you know anything about programming languages, their syntax, even semantics, their syntax, the way you should write it. If you don't write it that way, that means you can't get the needed results. So we want to check. If it's not correct, to tell us. If it is, to tell us. So if it's correct, it says success, the configuration is valid. If it's not, to give error. But in this case, it should give us success because it is correct. Alright. So if you probably miss if you miss a spelling, yeah, let's say I wrote let me go to if I wrote instead of AWS I wrote AW and I forgot. When I validate it, it will tell me you made a mistake. Go and check it, right? Because you can't proceed further if that issue is there. Taking some time. All right. Okay. Oh my God. Round up soon. Validating. Okay, it's done. Success. Can you see? It's correct. If there's anything that is not correct yet, it says not correct. You can try it out. You can remove one and put it. If it's not correct, it will show you that it's not correct. So we want to create our infrastructure now. We've gone through the process. We want to create our infrastructure. So there are two main steps. If you read through here, the first thing is that is your plan and apply. So what plan does for you is that it shows you what exactly Terraform wants to execute, which I will show you. All right. Before it executes it, this is what I'm going to do before I do it, something of that nature, right? So that you can check if there's anything that is not the way you expect it to be, and you can make changes, right? That's what Terraform plan does. And then Terraform apply, now basically apply the changes, like the name sounds, apply the changes, right? It executes those things that Terraform have told you it wants to do, right? And the last command, right, is the Terraform destroy. It deletes the infrastructure you've applied, right? Basically cancels it. Okay, it's running, right? It's running, so give you some time. Let's see. Okay. So for this particular configuration file that I've wrote, you will see that it says your configuration includes a single resource. What's that single resource? The AWS instance, which is the resource name, and then yes, the resource name. No, this is the resource itself. Sorry, the resource and the resource name. If there's anything I forget or you forget, you can check back. As I have the documentation, there's nothing to, what's the word, cram also. Okay, it's the resource type. It's a type. There are different types of resource, and then the resource name. So it has shown me the plan, and you can see here. So here's the plan, right? It basically reads through my configuration file. So it says data.aws.ubuntu. It reads through it and says, after reading through it, it picks the ID, which is what we have here. It picks this ID, right? The ID that I'm talking about. This is it. From everything that we have here, that we have inputted, this is the specific ID. It's very specific, to this Ubuntu Noble 24 is specific. So this plus sign tells you what Terraform wants to create. If I'm trying to destroy it, you will see a minus sign and the color is red. If I'm trying to update something, you will see that the sign here will be yellow. I think it should be plus but in yellow format, if I'm not mistaken. But for what we have here, these are the things that AWS Terraform wants to create for you. The AMI is specified, right? ARR we did not specify it. So what Terraform does in conjunction with AWS is that it just picks the default value for you, right? Because we didn't specify these basic things. All this we didn't specify. The things that will specify the things that it will make sure it uses. The remaining things are known after apply. As I said, that what we are doing, you can see the region specified it. The name for the institutions that we specified it. So every other thing is known after apply. So it picks the default version, right? The default on AWS. Like for instance now, the default you just put an IP address by default, but we can specify an IP address to be there, right? But since this is just basic, let's continue. So these are everything is fine, is good. So what do? I click Terraform and clear my screen. Terraform, apply, and I click. So in this part now, it will do the same thing as planned, but it will give me a prompt to either say yes or no for you to go ahead or not. But I will now put yes so that we can see what has been created. So we're done with this exact thing that is here. So it will tell me to enter a value like you see here, and then I'll put yes, and then I'll put yes like this, and then it will start creating it. And it will be done in a few seconds, like you see here. In 40 seconds it was done. So, and I can see through my EC2 console, which I'm going to show you, but let's just give it some time. Okay, just a minute. So can you see now? Yes, I will put yes. Okay, and so it's creating, as you can see. I named my web saver, so that's why it's speaking. But in this, it was app saver they call it. So the names are not restricted, are just names. So it's creating 10 seconds. Let's see how long it will take here. So 20 seconds. It's taking more time here. I think it's depending on the internet connection. But it should be done in less than a minute. So when it's done, so it took 39 seconds here. So it's depending on your connection. Here it took 14 seconds. It's faster there. So let's check. It has been created. Meaning, what has happened now is that what our AWS provider has Terraform has looked at our configuration. It says that I want to create an EC2 instance called Learning Terraform, right? With this specific ID, which is what is here, and with that, the Terraform provider has been used to communicate with the AWS API, and then they've been able to communicate and say, this is what I want to do. All right, these are the required details that I need, and this is what I want to do exactly. All right, do it for me. And AWS has done it. So if I check here, which let's look at now. If I check here, you will see something interesting. You see that. Okay, let's see. It's loading. So let me go to my instances. Nothing was here before, right? So I will show you. So now you will see that an instance has been created here. So Learning Terraform, that's the name we gave it. And I've already picked. It's running, it's T2 micro like we specified. And you see that initialize, meaning it's just coming up, right? It's coming up because we just launched it, right? Can you see US West 2A? We didn't specify this, so we picked this up because there are different availability zones. There are US 2A, 2B, and a lot. But we didn't, so we just picked by default, like I told you, right? And it has given us a public IPv4 DNS. All these details were picked up. Can you see? It says default. So it goes to default setting for the things that we did not specify exactly for it. So you can see we have an instance up now. Let me just refresh. Sorry, I'm refresh to see what we have. So is up and running now, right? Beautiful. So that's exact way to create an EC2 instance. So we can even do many things. We can do some amazing things, amazing things, right? With this, we can. Let me see where we can do that. We can say, I think we can use the count. I think we can use count. 5. I think so. Is it here? Let's see. Yeah, you can use the count argument to show how many instances we want to create. So I want to create like 5 instances now, for instance. So you will see when I applied it, it will populate 5 instances here immediately. Let's try it out, then we'll wrap it up. So and this is not formatted, because if it's formatted, it's meant to be like this. Let's go through the whole process again. Terraform FM format, right? Okay, there's an issue with what I typed, Terraform FMT. Then after this, I would validate it using the command terraform validate, right? Terraform validate. Then after this, you can check what is next, right? You don't have to have everything on your head. I'm validating. After formatting validates, it's already initialized, so we don't need to really reinitialize it again, except we probably change the provider they want to initialize so that you can install that new provider. But if you have that already, we don't need to initialize again. Even though you initialize, it doesn't change anything. It's just it still remains the same, so there's no point. Validates. So we can, after this now, we just go and apply. Let's see. Let me clear my screen. Clear my screen. Okay, it's still trying to validate. But I can clear my screen over here. Let's give it some time to validate. So if I validate and apply now, you will see that it will populate 5 instances of the same exact specifications that we have already, exact one. So just like having 5 replica of the same thing. So that's what's going to happen. Terraform just happened now. I'm not sure. Let me try it again. Terraform validate, then we apply, then we see it, and then when we are done with that, we destroy the resource quickly so that I don't pile up cost on AWS. Yeah. I could have paused this so that you don't have to wait like this, but I don't think I have been able to pause from here. So just you can fast forward this part. So it's valid. Can you see? So you can actually have a count to yeah. So I'm just showing that there are many things you can do, which everything is included in the documentation, right? You can just check them out. If you're trying to do something, check it out. So let's apply quickly, and then look at what we want to do. Is it fine? Then before we click yes, although if you believe that everything is fine and you don't want Terraform to prompt you to say yes or no, there's a way you can do it. You can just do Terraform apply - auto approve. It just keep on moving. It won't ask you yes or no. Basically, that's all you do. Yeah, but taking it one step at a time. One step at a time. One step at a time. Taking some time. I mean, so like you can see now, it's reading, all right. Okay, let's check what we have here. It's quite long. Wow, this is long. Okay, so it's saying that okay, Terraform will perform these actions. AWS instance of web server has moved to AWS instance web server 0. So it's counting 1, 2, 3, 4, like you know how you count in programming languages index. So now let's see, 40 unchanged attributes, 9 unchanged blocks hidden. So AWS is to create number 1. Can you see that this one that we have normally as assume 0? You know in index in programming you have, if you want to do 5 things, you start from 0, 0, 1, 2, 3, 4. So this one has assumed 0. This one is, the next one is number 1 with this detail, right? With this AMI 0786. Then let's see, let's go down the normal thing that we have. This one is 2 with this. If you look at these details, they are the same. They're just replica of the same thing. We go down again. Number 3, can you see that again? The same one, it did not change. Then number 4 is the last one, which makes it 5. Then let's go on to say yes. And then when it's done, I'll just check I'll refresh here and we'll look at here. Let me reduce this. Okay, so it's done. Let's just wait for it. We're almost done. So I'm sure that this would break down every single detail, because it's creating what I found out, right, from my own experience, is that we just in the bit to want to do something, just chasing the results, which is good, but the process is not really understood. You cannot replicate it, and you can even have issues when things are changing, because the world in tech keeps changing, but the fundamentals are right. You can learn anything. So it's creating, can you see, 2, 3, 2, 4, 3, 1. Basically it's creating them. It says creation complete for number 2. This create is complete. Alright, let's see, number 4 is complete, number 1, number 3 is complete. 0 does not change. Just remember that 0 has been created already. It just assumes number 0. It's not that we created, just assume number 0. It's still there. It just assumes a new position. Then the 1, 2, 3, 4 has to be created. So if I come here, let me increase this. If I come here and I refresh, you'll see that we have 5 instances now. 5. So can you see this now? How can I? So you can see 1, 2, 3, 4, 5. Okay, I can bring this down. So you can see 1, 2, 3, 4, 5. You can even do it such that the names is 0, 1, 3, 4, 5. You can do a lot of things. You can play with it. Amazing stuff with it, right? So this is it here. So very quickly, let's destroy it so that we round it up. Terraform destroy. So destroy, what this command does is that it destroys everything you have done. Because, okay, I didn't see this part, sorry. Because in this place now, I can see these 2 things were not here before. TF state were not here before. It was when we applied our first change in infrastructure to create an EC2 instance that this come up. And what this does, right, is that it just uses to track the state of the infrastructure that has been created. It just keeps a record of it, such that when I'm trying to, like, for instance, I was trying to create 5 now. What Terraform was doing, that it looks at what I have already and it looks at what I'm trying to now do now. I have just 1 instance. I'm trying to create 5 now. So it knows what changes to make. This one that I have, I need to create 4 more of it. So you can see that when we're doing that, the first one assumes 0. and then it creates 1, 2, 3, 4. So that's why the state file is very important. If you lose the state file, you cannot. Terraform does not have any memory of what you've created, right? So it's important that the state file is kept, is very sensitive file, and the state file contains sensitive information, so you have to like keep it. You don't put it in your GitHub repository yourself. You keep it in a safe place, maybe on your local system, but generally you can store it in different ways, which I don't want to go into. But you can store it using S3 backend. You can store it using, let's see what Terraform recommends here in their platform. Terraform says that you can store it. Let's see. Can you see this now? It says when you use Terraform to plan and apply changes to your workspace infrastructure, Terraform compares the last known state of your state file, your current configuration, and data returned by your provider to create it. So there are three things actually in place. The last known state of your infrastructure, which is going to be recorded in this state file. Then your current configuration. I want to make my EC2 instance from 1 to 5. Then it says data returned from your provider to create its execution plan, which is what you see when you say Terraform apply. It brings us an execution plan. And it says that your state file can include sensitive information about your infrastructure, which I just said now, such as password, security keys. So you must store your state file securely and restrict access only to those who need to manage your infrastructure, because if people have access to that, they can do and undo with your infrastructure, and you don't want that. You want to prevent things like that. As even hackers, people that can have access to it and mess it up. Even apart from even hackers, there can be some employees that probably don't even know how this thing really works. Junior developers, if you have access to it, they can just run a command mistakenly and it affects the whole organization. So these things are things that you want to avoid. You have to store them securely and only restrict access to people that needs to manage infrastructure, like let's say your admin, your senior DevOps engineer, and the likes, administrators. By default, Terraform creates your state file locally. So I have this on my system. As your state file operations mature, let's say it increases, you are doing more infrastructure, storing your state file remotely using HCP Terraform will let you collaborate with your team more easily and keep your state file secure. So you see that it's recommended for you what you can use to store your state file when it's increasing, because in an organization setup, you will create a lot of things, and as it grows, your state file becomes more bigger and bigger. So you can use this to store it. Yeah, that is not the only way. You can use S3 backend, which we are not discussing in this. But what this tutorial is for is to be able to provision an EC2 instance with Terraform and understanding all the process. So I just ran Terraform destroy now. It's waiting for me to put in a command. Yes, can you see what I just said now? Oh, there's a lot here. You can see the minus sign that is red. It means it wants to destroy these things, right? Will be destroyed. It's just telling you will be destroyed, informing you before you click the button. Oh my god. Let me see. I'm just trying to check something quickly. Okay, that's okay. That's no problem. So it's telling you that all these things will be destroyed. So if I click yes, I don't want to go into some details that are not within the scope of this. So can round this up. So I've said yes. So now it says it's even telling you Terraform will destroy all your managed infrastructure as shown above. This is no undo. Only yes to be accepted to confirm it. Okay, there is no to undo, sorry. You can say no. But if you say yes, it's destroying everything. You can create it back, right? If you apply again, because Terraform has recorded that state already, so you can replicate it back again. That's the beauty of having Terraform. So it's destroying. So when I come to my when I come here and I open this place, right, and I try to refresh it, you will see that since I initialize, you will see now that I'm terminating, right? Meaning I'm deleting them. Let's see that. Let me do it side by side so that you can see what I'm talking about. So can you see? It says resources 5 are destroyed, meaning my 5 instances have been destroyed. Let me confirm that from here. So if you look at here, terminated, everything has terminated. If I refresh it, meaning it has deleted everything. So it's still showing here like this, but it has been deleted. So after like a 1 or 2 minutes, you want to see it here again, right? You want to see that it has deleted it. So this is how to create infrastructure, or let's say create an EC2 instance on AWS using Terraform. Yeah, so it won't show again, right? But I don't want to wait here. It has terminated, like you can see, and it has shown those here over here to that it's completely destroyed. So that's the whole process of your infrastructure. You can see from here, these are the state file. It records everything that you've done, everything, so that it can use that to compare with, let's say, what you want to now do again. Let's say for now I want to recreate everything back again. It looks at, okay, you did everything was destroyed before, you want to create it back again. Okay, now I know what to do. I want to create 5 of what I deleted before, so to start again. You get my point? So that's it. The log file here is for your version. You need to store the version that has been installed and downloaded and installed. So that's about that. So I believe that this session was able to take you through every single thing that needs to be understood. If there's any question, anything that you need to be clarified about, or let's say we are doing this and you run into an issue, you can leave a comment below. I would look at it and check it out. Thank you very much. Yeah, see you in the next